Hello friends, welcome back to my YouTube channel. This is part number 2 of my discussion on adsorption, and today I will be talking about industrial adsorbents. So I will let you know important adsorbents that are used for a variety of purposes in the industry. So that's why I have given a title to this discussion as industrial adsorbents. So at the end of this discussion, you will know about various adsorbents that are in use for different separation tasks. So let us begin the discussion. Okay, to begin with, we will start or we will understand or we will know more about Fuller's earths, which are used as adsorbents in various applications. So these are natural clays. Chiefly, they are magnesium aluminum silicates in the form of the minerals Attapulgite and Montmorillonite. So they are present in the form of minerals Attapulgite and Montmorillonite, and they are chiefly magnesium aluminum silicates. We know them as natural clays. How they are prepared or how they are converted into adsorbents, let us know. So what is done? These clays are heated and dried. Two tasks are carried out. First, they are heated and then dried. The clays are heated and dried. And due to these two operations, what happens? A porous structure is developed in them. So the heating action and then drying of these clays, it results in development of porous structure in them. And porous structure is very essential for the adsorbent. So the clays are heated and dried, which results in the development of a porous structure in them. Then after that, they are grounded and screened. After you have the porous structure developed in them, they are grounded and they are screened. And then you can use them as adsorbents. Now, what are the applications for Fuller's earths? They are used in decolorizing, neutralizing and drying of petroleum products. One of the applications, the petroleum products, you have lubricating oils, then transformer oils, kerosene and gasoline. So the decolorizing of all these petroleum products, the neutralizing of all these petroleum products and drying of all these petroleum products, it is in these applications, Fuller's earths, they are used as adsorbents. Then they are also used for decolorizing, neutralizing and drying of vegetable and animal oils. So oils that are obtained from vegetables and animals, in order to decolorize them or neutralize them or in order to remove moisture from them, Fuller's earths, they are used as adsorbents. So this is another application for them. Then after you have used it for a sufficiently long time, and when they get saturated, you can regenerate them so that you can use these Fuller's earths in new adsorption operation. So how is this regeneration carried out? The regeneration is carried out by washing and burning the organic matter that has adsorbed on their surface. So in this way, this is brief information about Fuller's earths, which are used as adsorbents in these applications: decolorizing of petroleum products, decolorizing of vegetable and animal oils, even neutralizing and drying of petroleum products, and the neutralizing and drying of vegetable and animal oils. So Fuller's earths, these are basically natural clays Chiefly, they are magnesium aluminum silicates, which are present in the form of minerals attapulgite and montmorillonite, and they have to be prepared in order to make them suitable. How the preparation is carried out? They are heated and dried. The clays are heated and dried. Due to this, a porous structure develops in them, and then after that they are grounded and screened, and then they are used in the adsorption operation. You can regenerate them. How that is done? That is done by washing and burning the organic matter that has adsorbed on their surface. So this is all about Fuller's earths. Little information about Fuller's earths. Okay, now the next one are activated clays. These are basically bentonite or other clays which have to be activated in order to use them as adsorbents. So essentially, no adsorptive ability unless activated. That means in their natural form, they are not useful as adsorbents, because in that state, they essentially doesn't have any adsorptive ability. So we need to activate them, and that's why we are calling them activated clays. So essentially, they don't have any adsorptive ability unless activated. So activation is necessary. And how is this carried out? Activation is carried out by treating them with sulfuric acid or hydrochloric acid. So first step is to treat them with sulfuric acid or hydrochloric acid, and then after that they are washed, dried and ground to fine powder. And once they are converted to fine powder after treatment with sulfuric acid and hydrochloric acid, they are now ready to be used as adsorbents. So activation is important. In their natural state, in their natural form, they don't have any adsorptive ability. We need to activate them. So activation is an important step in this case. So activation is carried out by treating them with sulfuric acid or hydrochloric acid, and then after this treatment they are washed, dried and ground to fine powder, and then they can be used as adsorbents. So what are the applications for this adsorbents? This activated clays, they are used in decolorization of various petroleum products. So decolorization of petroleum products is one of the application, or you can say the only application, the only important application for activated clays. And as far as regeneration is concerned, usually activated clays, they are discarded after single use. There is no attempt of regenerating it. After single use, they are discarded. That is usually what is done. So activated clays, these are bentonite or other clays which essentially have no adsorptive ability unless activated. Therefore, activation is necessary. Activation is done by treating them with sulfuric acid or hydrochloric acid, and then they are washed, dried and converted to fine powder or ground to fine powder. And the major application for activated clays is decolorization of petroleum products, and there is no any regeneration. Usually they are discarded after single use. So that is all about activated clays. Okay, the next one is bauxite. What is this? This is naturally occurring hydrated alumina. No adsorptive ability unless activated. So in its natural state, it doesn't have any adsorptive ability. We need to activate them. How is the activation carried out? It is heated to temperatures varying from 230 degrees Celsius to 815 degrees Celsius. And after activation, then you can use it for decolorizing of petroleum products. Then you can use it for drying of gases. Major applications for bauxite: decolorization of petroleum products, drying of gases. You can regenerate it after use. In order to reuse it, you can regenerate it. And how are you going to do that? The regeneration is carried out by heating it. So that is little information about bauxite, one of the adsorbent. It is naturally occurring hydrated alumina. Essentially, in its natural state, it doesn't have any adsorptive ability unless it is activated. How the activation is carried out? It is carried out by heating it to temperatures in the range from 230 degrees Celsius to 815 degrees Celsius. And after it is activated, you can use it for decolorization of petroleum products. You can use it for drying of gases. And after it gets saturated, you can regenerate it by heating. So that's all about bauxite. Now let us move ahead. The next adsorbent that we will be talking about is alumina. It is hard hydrated aluminum oxide. It is basically hard hydrated aluminum oxide. In its natural state, it doesn't have any adsorptive ability. It has to be activated. So it is also called, you can call it as, or it is also known as activated alumina. Activated alumina. That the point is, it has to be activated. So no adsorptive ability unless activated. How is the activation carried out? It is heated to drive off the moisture. So the moisture, in order to remove the moisture, it is heated, and then it will be ready for adsorption task. What are the applications for activated alumina? It is used as a desiccant for gases and liquids, which will remove moisture from this gases and liquids. So it is used as desiccant for gases and liquids, that is drying of gases and liquids. This is one application. The major application for activated alumina. You can regenerate it after it gets saturated. It can be regenerated. And how this is done? It can be regenerated by a variety of methods. You can regenerate it, and then you can use it for new adsorption operations. So that is all about activated alumina. It is hard hydrated aluminum oxide. Essentially, it has no adsorptive ability unless activated. It is activated by heating it to dry off the moisture. It is used as a desiccant for gases and liquids, that is for drying gases and liquids, and you can regenerate it by a variety of methods. So that is all about activated alumina. Let us move ahead. Then let us talk about the next adsorbent, which is bone char. This is porous black granular material. Porous black and granular material. It is obtained from animal bones. It is obtained from animal bones that you have. That's why you have the word bone in its name. So it is obtained from animal bones. How it is done? It is done by destructive distillation of crushed dried bones at temperatures in the range from 600 degrees Celsius to 900 degrees Celsius. So destructive distillation is carried out of these bones, animal bones, which are first crushed and dry, and then the destructive distillation is carried out. Destructive distillation is carried out at temperatures in the range of 600 degrees Celsius to 900 degrees Celsius. What are the applications for bone char? It is used chiefly in the refining of sugar. The major application for bone char is in the refining of sugar. You can regenerate it. How you can do that? The regeneration can be carried out after washing and burning. So washing and burning will regenerate bone char after it gets saturated, and then you can use it in new adsorption applications. So bone char, it is a porous black granular material which is obtained from animal bones. This animal bones, they are crushed, dried, and then destructive distillation of this bones is carried out at temperatures between 600 degrees Celsius to 900 degrees Celsius. Once ready, they are majorly used in refining of sugar, and once they get saturated, you can regenerate them. Regeneration will be done by washing and burning. So that is all about bone char. Little information about bone char, which is one of the adsorbent that is used. Then the next one is activated carbon. What is it? Activated carbon, it is also called decolorizing carbon. It is the oldest known adsorbent. It is the oldest known adsorbent. It is a microcrystalline product that is obtained by thermal decomposition of carbonaceous material. So the major thing is these activated carbon, it is obtained by thermal decomposition of any carbonaceous material. And thermal decomposition of any carbonaceous materials will result in a microcrystalline product that can be used as adsorbent, or which is the activated carbon. So which are these carbonaceous materials? So you can use sawdust, wood, vegetable shells, coconut shells, coal, etc. So you have a variety of carbonaceous materials that can be used for manufacturing activated carbon. The only thing that is to be done is thermal decomposition of this carbonaceous materials. So this results in microcrystalline product which can be used as adsorbent. So thermal decomposition is carried out in an inert atmosphere at a temperature of about 800 Kelvin. Thermal decomposition is carried out at about 800 Kelvin. There are different methods of preparation and then activation of the adsorbent. So let us know about these methods of preparation and activation. First method, in the first method, the carbonaceous material is mixed with inorganic substances. For example, it could be mixed with calcium chloride. One of the method is the carbonaceous material is mixed with inorganic substance like calcium chloride, and then thermal decomposition of this mixture, the thermal decomposition of the resulting mixture will give us activated carbon. This is method number 1. And then you can, after the thermal decomposition step is finished, the next step is the organic matter is leached out in order to make the adsorbent ready for use. So in the first method there are 3 steps. In the first step, the carbonaceous material is mixed with inorganic substance such as calcium chloride. Then in the second step, thermal decomposition of this resulting mixture is carried out, and in the third step, the organic matter is then leached out in order to make the activated carbon ready for use. This is the first method. Then continuing with activated carbon, we were talking about methods of preparation and activation. We discussed method 1. Now method 2, in this method, the carbonaceous material, it is mixed with a porous material like pumice stones. So one type of stone. So any porous material like pumice stones is first mixed with carbonaceous material, and then this mixture is thermally decomposed. And this thermal decomposition results in deposition of the carbonaceous material throughout the porous structure. So that gives us the adsorbent that you can use. So in method 2, the carbonaceous material is mixed with a porous material. For example, it could be mixed with pumice stones. And then this mixture is thermally decomposed. So it results in the deposition of carbonaceous material throughout the porous structure. And then you can use it as adsorbent. Now the third method. In the third method, the carbonaceous material is thermally decomposed first thing, and then after this thermal decomposition, it is activated with hot air or steam. So you have thermal decomposition, the first step, and the second step is there is activation by using activation with hot air or steam. So these are the three methods which are in use for preparing activated carbon. Now, what are the applications for activated carbon? It is used for decolorizing of sugar solutions, then industrial chemicals, drugs, dry cleaning liquids. So these are the applications. Major application is decolorizing of all these products: sugar solutions, industrial chemicals, drugs, dry cleaning liquids. Then more applications for activated carbon. Activated carbon is used in water purification. It is used in refining of vegetable and animal oils. It is used in the recovery of gold and silver cyanide ore lead solution. So in order to recover the cyanide ore leach solution, gold and silver cyanide ore leach solution, activated carbon is used as adsorbent, and it can be used in powder form or granular form. So you can use it in a powdered form or it can be used in a granular form. It has low affinity for water. The main important property for activated carbon, it has low affinity for water, and therefore it is useful for removing components from aqueous solutions or moist gases. So it will hate water. It hates water. That is, it has low affinity for water, and therefore it is useful for removing components from aqueous solutions or even from moist gases. Then you have gas adsorbent carbon. It is activated carbon. It is nothing but activated carbon that is used for adsorbing components from gaseous mixtures. So these activated carbon, they are limited to adsorbing components from gaseous mixtures. So they are prepared by carbonization of carbonaceous material, that is thermal decomposition of carbonaceous material. It could be coconut shells, fruit pits, coal, lignite, wood. So these are different carbonaceous materials that can be used to get the gas adsorbent carbon. How the activation is carried out? Activation is carried out by partial oxidation. How this partial oxidation is carried out? It is carried out by treatment with hot water or steam. So after getting activated carbon, the product, after the thermal decomposition of any of this carbonaceous material, activation is carried out. Activation is done by partial oxidation, which is done by treatment with hot water or steam. What are the applications for gas adsorbent carbon? They are used in recovery of solvent vapors from gas mixtures. They are used as gas masks, and they are also used for collection of gasoline hydrocarbons from natural gas. So these are the applications. They are used for fractionation of hydrocarbon gases. So recovery of solvent vapors from gas mixtures is one of the applications. Then they are used as gas masks. They are used for collection of gasoline hydrocarbons from natural gas. They are used for fractionation of hydrocarbon gases. So these are various applications for gas adsorbent carbon. Then you can regenerate it. How are you going to do that? Regeneration is carried out by evaporating the adsorbed gases. That's it. Then you have molecular screening activated carbon, the other type of adsorbent that is used in industry. What is this? These are carbon molecular sheaves. They are known as carbon molecular sheaves. They are specially made from, these are specially made forms. They are, you can say that they are specially made items. They are specially made forms. How? By selecting proper starting material and activation process, you will be able to get a pore system with a narrow spore size distribution. So by selecting proper starting material, proper carbonaceous material, the starting material, and then proper selection of the activation process will give you a product that will have a pore system with a narrow spore size distribution, and that is important. So pore openings, it is controlled from 5 to 5.5 angstrom units. So pore opening, it is controlled, it is within 5 to 5.5 angstrom units. That is into 10 to the power minus 10 meter. So with this pore size, components of specific molecular diameters can only be admitted. So you will be able to allow only those components having diameters less than some specific value. So components of specific molecular diameters can only be admitted. For example, from the mixture of paraffins and isoparaffins, only paraffins can be admitted, while isoparaffins of larger molecular diameters, they can be rejected. So when you have a mixture of paraffins and isoparaffins have larger molecular diameters. So this adsorbent is going to reject them, whereas paraffins which have smaller molecular diameters, they will be admitted. And in this way, adsorption will be carried out. Now, what are the applications for this carbon molecular sheaves? The applications, they are used in fractionation of variety of compounds, acetylene compounds, alcohols, organic acids, ketones, aldehydes. So fractionation of all these compounds, it is possible by using molecular screening activated carbon or carbon molecular sheaves. So that is all about molecular screening activated carbon. Now let us move ahead. Then you have synthetic polymeric adsorbents. So in this case, synthetic material is used. In their preparation, synthetic material is used. Synthetic polymeric material is used. That's why the name is synthetic polymeric adsorbents. So they are made from polymers like styrene, divinyl benzene, acrylic esters, etc. So what is the nature of these adsorbents? They are porous spherical beads of 0.5 millimeter diameter. So these are available in the form of porous spherical beads, whose size is 0.5 mm. So each bead in turn is a collection of microspheres whose size could be 10 to the power minus 4 millimeter in diameter. So first you have this porous spherical beads whose diameter may be 0.5 mm, and then each bead itself has a collection of microspheres whose diameter may be as low as 10 to the power minus 4 millimeter. What are the applications for synthetic polymeric adsorbents? Those adsorbents which are made from styrene and divinyl benzene, they are used for adsorbing non-polar organics from aqueous solutions. So adsorbents which are made from styrene and divinyl benzene, they are used for adsorbing non-polar organics from aqueous solutions, whereas those adsorbents which are made from acrylic esters, they are used for adsorbing polar solutes from aqueous solutions. So depending on the requirement, you can use appropriate adsorbent in this case. Then you can regenerate this synthetic polymeric adsorbent. How it is done? It is done by leaching the adsorbed substance with low molecular weight alcohols or ketones. So regeneration will be carried out by leaching the adsorbed substance, and for that you can use low molecular weight alcohols or ketones as the solvent for leaching solvent. And then you have silica gel. So it is a hard, granular, very porous product, silica gel. It is hard, it is granular, and it is very porous product. It is made from a gel. What is this gel? The gel is precipitated by acid treatment of sodium silicate solutions. So sodium silicate solution, it is treated with acid to get this gel. And this gel is then used to make silica gel. The moisture content before use, the moisture content, it can vary from 4% to 7%. Then this silica gel, it is used in applications. Majorly it is used for dehydration of air and other gases, silica gel. And then it is also used in gas masks. Then it is used for fractionation of hydrocarbons. You can regenerate silica gel. How regeneration is carried out? It is carried out by evaporating the adsorbed matter. So silica gel, hard, granular, very porous product. It is made from a gel which is precipitated by the acid treatment of sodium silicate solution. So initially the moisture content of silica gel may be between 4% to 7%. Then you can use it for dehydration of air and other gases. You can use it in gas masks. You can use it for fractionation of hydrocarbons. And after it gets saturated, you can regenerate it by evaporating the adsorbed matter. So this is all about silica gel. Then you have molecular sheaves. Molecular sheaves. What are these? These are porous synthetic zeolite crystals or metal aluminosilicates. Porous synthetic zeolite crystals, metal aluminosilicates, and the cages of the crystal, the cages of the crystals, unit cells. So for example, let me tell you, if you have a cubic crystal, then a cube with simple cubic, you will be having a atom, or say the constituent particle at the each corner of this cube, and then this is the cage. So that this unit cell is called cage in this case. The cages of the crystal, it entraps adsorbed matter. So the adsorbed matter, it could be entering. Let me just show you. So the cage, let me first talk about it. The cages of the crystal entraps the adsorbed matter, and the crystal composition, the composition of the crystal can determine the size of the passageways. So the size of the passageways through which the adsorbed matter will be moving into this cage, it depends on the crystal composition. So the adsorbed material will be adsorbing within this cage, and the size of the passage, it depends on the composition of the crystal. So the cages of the crystal, it entraps the adsorbed matter. The crystal composition determines the size of the passageways. This regulates the size of the matter that can enter and get adsorbed. So which component or which substance can enter the cage, and which substance will then can get adsorbed, it will depend on the size of this passageways. And the size of the passageways, it is determined by the composition of the crystal. So besides the molecular size, the other thing that is used, uh, besides the molecular size, adsorption also occurs according to molecular polarity and then degree of saturation. So molecular polarity and degree of saturation, these are also used as a criteria for adsorbing various substances. What are the applications for molecular sheaves? They are used for dehydration of gases and then also liquids. They are used for separation of gas and liquid hydrocarbon mixtures, and you can regenerate them. How to regenerate them? They are regenerated by heating and elution. So you can regenerate by heating and elution of this molecular sheaves. So that is all about, that is little information about molecular sheaves. And with this, I end my discussion for today's video. I have discussed important industrial adsorbents that are being used for a variety of adsorption tasks. I also talked about what are those adsorbents, how they are prepared, how they are activated, what are the applications, how to regenerate them. So I hope you have learned something through this discussion. So let me end my discussion for this video. In my next video, I will be talking about adsorption equilibrium. So for this video, thanks for watching the video. Do subscribe to my channel, tell your friends to subscribe to it, and hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. For now, have a nice day and bye bye.